Hey everyone, this is Group 2A and this is our midterm review. We hope it helps.
French engineers studied math and science in classrooms and were trained to work for the state. Their formal training began when French Minister of War created the Corps of Engineers in the late 17th century. This was one of the first organized efforts to personalize engineering focused on building roads, bridges, and canals. Later in 1747, the National School of Bridges and Canals was established to provide even more specialized education. These engineers joined the school and became an elite group responsible for designing and maintaining national infrastructure. French engineering focused on theory, precision, and serving the government, with a strong emphasis on state-controlled projects. In Britain, engineering developed a little bit differently. It was more about practical skills and the industry rather than formal education. British engineers learned through apprenticeship and on-the-job experiences. Influential figures like Isambard Kingdom Brunel and George Stephenson became leaders of the Industrial Revolution, building railways, steam engines, and factories. Their projects were often funded by private companies, not the government. British engineering focused on innovation, practical work, and helping the industry grow, emphasizing on creativity and real-world problem solving. In short, French engineers were trained in school to work on government projects, while British engineers gained their skills through experience and helped drive industrial progress. Both styles have shaped how engineering is done today.
Ground was broken on the Erie Canal in 1817 in Rome, New York, and it was then completed 8 years later in 1825. Upon its completion, there was a ceremony called the Wedding of Waters, where a bucket of water from Lake Erie was poured into the Atlantic. The entire project ended up costing over $7 million, and it stretched 363 miles from Buffalo on Lake Erie in the west, all the way out to Albany on the Hudson, which then had access over to the Atlantic on the east. Many people benefited from the canal itself, including migrants and pioneers who were trying to get out west during the Western expansion, and merchants as well who were trying to expand their commerce, connecting the East Coast to the Great Lakes and beyond. Additionally, the canal provided more affordable means of travel compared to wagons. Additionally, it also cut a 6.5-week trip down to about 6 days. Then it was also considered America's first school of engineering. During that time, there were no dedicated schools to engineering. There were, let alone there were no trained engineers. So they had to learn on the job with new challenges. So with new challenges came new solutions and new equipment, including the tree stump puller, for example. The first challenge that they faced was the Montezuma Swamp in New York, where nearly 1,000 people ended up falling ill to malaria. They then learned that winter, despite the cold, was the best time for them to actually make progress on the canal because there was no mosquitoes. It provided a firmer terrain, and they could also put down wood pilings on the canal banks to prevent any erosion. Additionally, they encountered crisscross routes with lakes and streams, in which they ended up building aqueducts to counteract that. And the biggest challenge came around the Niagara Escarpment at Lockport, where they had to find a way to get these boats 60 feet up. And they ended up doing that by constructing 5 separate locks that got them up those 60 feet. It took 40 minutes per boat, and with that, they ended up making it over to the Great Lakes.
From 1815 to 1850, civil engineering projects such as the Erie Canal were mostly staffed by self-trained engineers. From 1880 to 1920, there was an increase in demand for highly trained engineers for advanced manufacturing. With the increase in demand came challenges for said engineers. One of the main challenges was how to balance business and professional interests. The solution to this came in the form of professional engineering societies. Professional engineering societies were created to help with status, increasing compensation, improving education, raising professional standards, and giving engineers some independence from employers. Engineering societies can include all engineering fields or be field-specific. The members of said societies may consist of engineers in management positions, employees of a company in a specific field, recent graduates, or highly trained professionals. Engineering societies may have varying criteria for membership. One that favors independent professionals, such as the American Society of Civil Engineers, may require members to have technical creativity and the ability to design engineering projects. A society that favors business interests, such as the American Institute of Mining Engineers, would prefer members with experience in designing engineering projects or have an affiliation with a company or industry that relates to the field. The American Society of Mechanical Engineers and the American Institute of Electrical Engineers aim to have both professional ethics and be business friendly. The ASCE, AIME, ASME, and AIEE were considered the founder societies of American engineering. By 1963, there were about 130 engineering societies covering a wide range of engineering fields.
Around 1900, we witnessed a fascinating shift in how innovation happened in America and Europe. The age of the lone inventor working in their workshop, think Edison's early days in Menlo Park, was gradually giving way to something new, the Industrial Research Laboratory. This transition tells us something profound about how technology evolves. In the late 1800s, independent inventors like Tesla and Bell made breakthrough discoveries working largely on their own. They embodied the romantic ideal of the solitary genius. But as technology became more complex and industry more competitive, companies realized they needed a more systematic approach to innovation. General Electric established one of the first industrial labs in 1900, followed by DuPont, Kodak, and others. These labs brought together teams of scientists and engineers, gave them resources and facilities, and pointed them toward practical problems. It was a new model of organized innovation. Yet this wasn't a clean break. Both models coexisted and often complemented each other. Independent inventors continued making crucial discoveries, but they increasingly collaborated with or sold their patents to large organizations that could develop and commercialize their ideas. The Wright brothers, for instance, worked independently, but eventually partnered with industry to develop their aircraft. What's particularly interesting is how these patterns reflected deeper economic and social changes. The rise of industrial labs paralleled the growth of large corporations, scientific education, and professional engineering. It marked a shift from invention as an art to innovation as a process. This period, around 1900, essentially created the modern research and development ecosystem, one where individual creativity and institutional resources work together to drive technological progress. The lessons from this era continue to influence how we think about innovation today.